The topic which we are going to discuss is sampling design. Now, as you can see, sample is a subset of the population. If we define a sample, sample is something which is the subset of a population, and we are having some key terms, keywords related to this. For example, you can see in this diagram the population, then we are having the target population, and then we are having the sample. So population come first, followed by target population, and followed by sample. So there are three words we will, there are keywords we will use. Population includes any unit on which your study will be applicable. Suppose you are testing the effect of corona vaccine. It means anybody who is suffering from corona in the world can be benefited by this study. If you are doing a study on online education, so it means anybody who is using online education or online method of education will be applicable. So population means anybody, anyone, whether it is a company, whether it is a people, right? Whether whatever be the unit. So whatever study you are doing, the result of this study will be applicable on each and everybody in the population. So this is the population. So population is defined irrespective of the geographical area. Population is defined irrespective of these limitations. So because whenever we are doing the study, the objective is to find out a solution for the population. I always against to these research topics. Like one of these research scholar, the title of the paper is that the behavior of the social media users in Bareilly city of UP. Now, when she showed me the paper, I asked them that who is the population in this paper? The population is the people who are living in Bareilly, or the people who are living all over India, or the people who are living all over the world. So first of all, tell me who is the population. So then she said Bareilly, because my area is Bareilly. Then I said, if you write that your population is the people in Bareilly, then nobody will publish your paper. Why? Number one, whenever you send your paper for publication, so they will find out where is Bareilly. And first of all, when they came to know that Bareilly is a small town in India, then they will lose their interest, because you are not addressing a global problem, you are addressing a very local problem. So this is absolutely wrong. So whenever you are write something, you should raise the global issue, the issue which is equally important in Europe, which is equally important in Russia, which is equally important in US, right? So the first of all, try to define your population. Means who will have the impact, or who will got the benefit from your paper. If I am saying that the investor in equity market is the population, it does not mean that I'm addressing only the equity investors of India. It means I should address equity investors of all over world, right? So first of all, you have to define what is the population, and keep your population as broad as possible. After that, there's a term known as target population. Now, what is this target population? So after explaining the population, you have to define what is your target population. For example, suppose I want to conduct a study on online teachers, or on the faculty members who are using online platform for teaching nowadays. Because I cannot have the data of the teachers in Russia, Europe, US, so I cannot approach them. So in my approach, I can ask only the teachers who are in India. So I will write that the target population of my study are the faculty members who belong to Delhi NCR, or who belong to different major cities in India, who are using the online education. And another example I'm giving you. So in Punjab, I was discussing with a doctor, and she said that I am doing a study on the cancer patients of PGI Chandigarh. Right. So she was collecting data from the cancer patients from PGI in the Chandigarh. Now, what is the population in this case? So she said that the population should be the cancer patients, and cancer patient. So then I asked that whatever study you are doing, is your study is equally applicable on the cancer patient who are in US, who are in Europe? Then she said yes. Because in medical science, we assume that if any medicine is good in India, it should be good in other countries also. So it means the population of the study is entire world. Then what is the target population? Now the target population is the patient in PGI Chandigarh. Even in PGI Chandigarh, maybe there may be 1,000 of cancer patients, and within the 1,000 of cancer patients, because she cannot take the data from each and every cancer patient, so she decided to take the sample of 50 or 100, right? So in this way we define the population. The target population here is the patient who are visiting PGI Chandigarh for the treatment, and sample is the how many people or how many cancer patient he included in the study will be the sample. So there are three concepts in the population: population, target population, and sample. So target population is a subset of the population, and sample is a subset of target population. So I hope you understand the difference between population, target population, and sample. So in your study, you should be very, very clear on three aspects: population, target population, and the sample. Okay, now let's move. So in this slide, there are some terms which I want to explain. So first, number one, element. And sometimes we call them unit. So elements are unit. I also call it unit. So what is the element or a unit? The element or a unit means from whom you are collecting the data. The element of or unit may be the individual. The unit may be the company. The unit may be the patient. Unit may be the student. The element or unit may be the customer. So you have to define from where, from whom I am going to collect the data. So this is called population unit or sample unit, because unit is same. And then there are two different terms which I wrote in this slide. One is the parameter, and second is the statistic. So parameter and the statistic, anything which you are measuring from the population, like the mean of the population, standard deviation of the population, right? This is called parameter. Anything which you measure from the population is called parameter. And the same thing when you measure from it in the sample, the same thing if you measure from the sample is called statistic. It's called statistic. So like this is the mean of the sample, standard deviation is the standard deviation of the sample. So when you measure anything of the population, it's called parameter. Anything, the same thing if you measure from the sample, this is called statistic. So we will use these words very frequently: parameter and statistic. Okay. Now, what is the purpose of sample study? The purpose of the sample study is that because you cannot get the data from the population, so you will collect the data from the sample, and whatever results comes, right? So you assume that it is equally applicable on the population. This property is called statistical inference. Statistical inference means whatever result you are drawing from the sample study should be applicable on the population. So you are doing the study on the sample, but you are concluding on the population. So you are making conclusion for the population. You are not making conclusion for the sample. So this property is known as statistical inference. So you can see that in the population, from the population, you pick a sample and you make results on the sample and you apply the results on the population. So this property is known as sample statistical inference. And one thing I'm also telling you, can we say this x bar is always equal to mu? So in this case, we cannot say the mean is always equal to the population mean. So rather we can say that the population mean is equal to sample mean plus minus margin of error. So this is the concept that the population mean should belong to this range. The statistic sample mean plus margin of error. Margin of error we calculate, as you know, that by this formula, and this is called margin of error. And with the help of this margin of error, we take lower limit and the upper limit of the sample statistic, right? So we will use this formula for calculation of the sample size in later slides, but I just introduce this concept because in the population the mu is exactly same, and but when we calculate the sample mean, the sample mean differ sample to sample, so there is a chance of some error. So because of this, there is a concept of margin of error in the statistical inference. Okay, so let's move Now, there are two types of study. One study is called census study, and second type of study we call it sample study. And I hope you understand what is census study and sample study. If you are getting the data from each and every unit of the population, this study is called census study. But what happens when you are doing census study? You require a lot of time. You require a lot of money to conduct. You require a lot of manpower to conduct census survey. So it is just impossible for a researcher to conduct census survey. Government of India conducted census survey every 10 years. So after every 10 years, they will collect the data from each and everybody from the population. And you know that they take the help of all the primary teachers in India. So whosoever is working with government schools are responsible for collecting the data from their region. So you can imagine that how much manpower is required to conduct census survey. And normally it took 3 years to complete the survey. Normally, the government took three complete years to conduct the survey. But in a PhD program, we know that we are never conduct the census survey. Most of the research papers are based on sample survey, and this sample size is very important for the papers. Now, sample study, as you know that we are take the data from a small portion of the census and will conduct the study on that. So that is known as sample study. Now, when we do the sample study, we should remember the three laws. So these are the three laws related to the sample study. Let me discuss that. So these three laws you can see here, like central limit theorem, law of large number, law of random selection. Central limit theorem say that if you increase the sample size, the distribution of the variables tends to be normal. I repeat, if you increase the sample size, the distribution of the variables tends to be normal. जितना ज्यादा आप सैंपल साइज बढ़ाते जाएंगे, आपका वेरिएबल्स का डिस्ट्रीब्यूशन नॉर्मल होता जाएगा. Now we are having second law, law of large number. The law of large number say when you increase the sample size, the accuracy of the results will increase. The accuracy of the result will increase. So you are getting better results with large population, large sample, and you are getting variation or inaccurate results when the sample size is less. And there is a third law. This is the law of random selection, which say that if you pick the samples randomly, you will get the more accurate results rather than if you take the samples not randomly. So higher is the randomness in the selection, more accurate results you will get. Right. So there are three laws which are helpful, very, very helpful in designing the results of your study. In most of the studies, if your sample size is large, so we will give more focus on these studies because the accuracy of these results are high. So like for example, in meta-analysis, we always give more weight to those studies where sample size is large, and we always give less weight to those studies where sample size is small. So sample size is a very important part of the research paper, research work, and you have to justify your sample size. How we can justify the sample size, we are going to discuss. I hope you understand the central limit theorem. So I just repeat once again. Central limit theorem say that if your sample size increases, the distribution of the variables tends to be normal. Law of large number say that if you increase your sample size, you will get more accurate results. Random selection say that if you select your sampling units randomly, you will get more accurate results. So these are the three laws which are very important in defining the results of the sample survey. Okay, now this is a simple comparison when we should apply sample survey, when we should apply census survey. So I'm not giving more focus to this slide because we know that in any case we have to apply sample survey. We never go to census survey. Census survey is only possible that when your sample size, when your population is very small. Otherwise, you cannot go for census survey. So this slide I'm not discussing because we always conducted the sample surveys. Now, what is the sampling design? So whenever I say sampling design, so what is the sampling design actually? Sampling design, first of all, you have to define the population. Then you have to define the target population. Then you have to define the sampling frame. Then sampling technique, sample size, sampling process. Now, I am saying two words here: sampling frame and sample size and target population. So what is the difference between sampling frame and target population? Let's understand this. Because I have a lot of discussion with different scholars, and I always find out that they are not having clarity between the target population and the sampling frame. So if anybody is having the idea, so kindly write in the chat box so that I can understand whether you understand the sampling frame or not. My simple question is that what is the difference between sampling frame and the target population? So no answer is coming. Okay. So you are making some guess. Yeah, but Rajiv ji and AP Singh gave some right answer. Yeah. So let me explain the difference between the sampling frame and the sample. In this slide, I define all the concepts. Suppose I want to collect the data from the faculty members in or who are using the online platform. So I will go to the websites of the universities and collect the list of faculty members there. And from the list, I will pick some of the faculty members. Or a telephone directory is also provide me the list, and I can go to the universities and can ask them the list of students who are doing the course. Similarly, I can go to the hospital and they can provide me the list of patients. So basically, the list of the population units or list of the population units from where you are selecting the sample is basically known as sampling frame. So sampling frame is basically the list of the units in the target population, which can be the part of your sample, is known as sampling frame. So whenever you define the sampling design, first of all, you have to define the unit, then you have to define the population, then you have to define the target population. After that, you have to define the sampling frame. So sampling frame means from which source you came to know about your population or the target population. Like for example, yesterday I was discussing with a scholar, and she is saying that I'm collecting the data from the employees who are working with the IT sector companies. Now I ask that, okay, if you are collecting the data from the employees working with IT sector companies, how you find out the data? So from where you got the list of the employees who are working with the IT sector? So what is actually the sampling frame? So आपका sampling frame है क्या? Now in this case, if we discuss the one by one, in this case the unit is the employee working with the IT sector unit. This is the unit of the population. Then target population is anybody who is the employee. Anybody who is the employee of the IT sector company is the population, whether it is India, whether it is US, or whether it is any other country. Then target population means the employee of the IT sector company which is located in Delhi NCR. So this is the target population. Now after that, I ask that now what is the sampling frame? So how you find out how you find out the employees? So in this case, the scholars say that I approach the HR managers to find out the list of the employees of the IT sector companies. Then I ask, do you think the HR managers will give you the list very easily and without any problem? It is not practically possible that you approach HR managers of the companies and they will provide you list very easily. So what is the sampling frame? Tell me what is the sampling frame, right? So my point is that in most of the cases, the scholar is not aware about the sampling frame. Similarly, if you are writing a paper, you don't know what is the sampling frame in my study, right? So sampling frame is a problem, is really a problem if you are not having clarity on the sampling frame. Sampling frame is the source or the list or the some information where you can pick your sampling units. Otherwise, without any sampling frame, it is just impossible to find out the sampling units. So I hope you understand what is the sampling frame. Other sampling frame is the list of the units which can be the part of your sample, right? So after defining the sampling frame, then you have to define the sampling technique. So we are moving toward the sampling technique. So this is the sampling frame. So if we compare population, the red line is explaining the population. Then we are having the sampling frame, and in the sampling frame we pick a sample, and within the sample there are many people who are not giving the responses, and I can get the responses from some of them. So this is called response error, right? Normally if you request 100 people to provide the response, only 20 of them will give you the response. So this response error is very high in the studies. Okay. So one thing is very clear here. The sampling frame is related to the target population, because you have to find out your sample from the sampling frame, and sampling frame is the detail of the target population. So I hope it is clear. And yeah, now let's move. After the sampling frame, the next topic which we are going to discuss is the sampling technique. We divide the sampling technique in two categories. One is the probability sampling technique, which I mentioned here, and the second method is called non-probability sampling technique. Okay, now I'm giving you some examples. Suppose there is a lottery system, and you apply for a lottery system. So what happens in the lottery system, that the company will pick out any 100 names, and whosoever is coming out, he won the amount. Suppose you buy some lottery ticket, and there are two people, X and Y, and both buy the lottery ticket. So what do you think? Who is having more chances to win the lottery, whether X or Y? So you know that in a lottery system, the chances of winning the lottery for X and Y are equal. This probability is called probability sampling technique. So we define the probability sampling technique as a method where the probability of each and every unit in the target population to be the part of the sample is equal. The probability of the units in target population to be the part of the sample is equal, then this is called probability sampling technique. Now in non-probability sampling, suppose your boss say that I am going to promote any two people in this in the department. So do you think your chance is equal to the chance of anybody else? So can we say the chances of each and everybody is equal? So here, because I know that there is a lot of corporate nepotism exist, and the chances of some are very high and the chances of some are very low. So in this case, the probability is not equal. Similarly, when you are picking the sampling units from the target population, the chances of some to be the part of your sample is very high, and the chances of some people to be the part of sample is very low. So in this case, we can say that this probability method is called non-probability sampling methods. So when the probability of each and every unit in the target population is equal to be the part of the sample, then this method is called probability sampling technique. And when the chances of different people are different, so the chances of some to be the part of sample are high, and the chances of some to be the part of sample are low. This is called non-probability sampling. So now we are going to discuss the different type of probability sampling and non-probability sampling. Let's start with non-probability sampling. So first of all, I'm explaining the non-probability sampling, like convenience sampling. So when you give a task to your students, they will always go for convenience sampling. I have seen in my life, whether they are the student of any college, whether it is a university college, whether it is a local college, whether it is a top college. In all the cases, students go for convenience sampling, right? So convenience sampling means whosoever is available, take the data from there. जो भी मिल जाए, convenience sampling का मतलब है कि जो भी मिल जाए. So anybody who is available, take the data from there. Then it is known as convenience sampling, right? Convenience sampling. So you can see that this person who is standing in the between the red circle, so the three persons are approachable to him, so he collect the data from these three people. So this method is known as convenience sampling. In convenience sampling, we do not apply our mind whether I should collect the data from these units or not, and without applying our mind we will take the data. And in most of the PhD thesis, I know that the researcher go for convenience sampling, but the problem is that you cannot write in your thesis or in the research paper that I went for convenience sampling. It is not a recommended method of sampling. Why? Because convenience sampling may lead to a lot of biasness in the data. There is a lot of biasness in the data set if you go for convenience sampling. This is the problem of convenience sampling. So करते सभी convenience sampling ही है, लेकिन इसको लिखना नहीं चाहिए. You should not write convenience sampling in the paper or the thesis. Now, next sampling is known as judgmental sampling. So Indians, according to Indian authors, this sampling is purposive sampling. And according to the standardized books of research methodology, they call it judgmental sampling. Right. So there is no difference between purposive sampling and the judgmental sampling. So what happens in judgmental sampling? You decide some criteria. You decide some criteria. For example, like in online teaching case, suppose I want to collect the data from the teachers who are adopting the online teaching. So what criteria I can make? Some criteria I can make, like the faculty member should have at least 5-year experience in teaching. The faculty must teach at least 2 subjects in online teaching model. The faculty member must spend at least 100 hours or 30 hours with online teaching method, right? So if you decide these criteria, right? So if you go for data collection and ask then whether you taught any subject in online teaching mode, right? How many experience you have in the teaching? If he qualify the criteria, then only you will collect the data from these people. So this method is called judgmental sampling. Another example I'm giving to you. In one study, we have decided to collect the data from the business travelers who take the services of Ola and Uber. Now we put some criteria. Like one of the criteria is that you must have at least 50 services from Ola and Uber. They must take the services in at least 3 different cities in India, and they must have Ola and Uber app on their mobile phones. So these are the conditions we put for before collecting the data. So anybody who is qualifying these conditions, we will collect the data from them. Otherwise, we reject them. We will not collect the data if they are not qualifying the criteria. So in judgmental sampling or in purposive sampling, we define the criteria, and anybody who is qualifying the criteria will be the part of the sample. Otherwise, we will not take the data from there. In one of the study, um, what happened? The scholar was interested to study the visitors of malls, and the topic is something like the shopping behavior of the visitors in a mall. Now, when we got the data, and we found that there are many visitors who are frequently visiting the malls, but the shopping is zero. They are not doing any shopping, but they are just coming to the mall and go back. So when we check the profiles of these customers, we found that all these frequent visitors are basically the college students of the nearby areas, and they bunk the classes, come to the mall, and after spending some time there, they go back. So now the question is that should we collect the data from these students? Are they really shoppers? Right? No. So basically, this judgmental sampling will help you in selecting the sampling units from whom we should collect the data, from whom we should not collect the data. So that's why I always suggest that if you are going to judgmental sampling, better you define at least 3 criteria. If the respondent qualify these criteria, then you should collect the data. Otherwise, you should not collect the data from these people. So this method is called judgmental sampling. After the judgmental sampling, now we are having the quota sampling. Quota sampling, as we know that government is having 50% quota for general, then some quota for SC candidates, some quota for ST candidates. So the same meaning we apply in the quota sampling. If you, like for example, in one of the study where we collected the data from the faculty members in the university system, we decided that the 60% responses we should collect from the assistant professor, 30% responses we should collect from the associate professor, and 10% responses we should collect from the professor. And the reason is very simple. According to the UGC and AICTE rules, the ratio of assistant professor, associate professor, and professor is, I think, 10:3:1. Some I do not exactly know the ratio, but there is a ratio decided by these organizations. So in that case, we decided to go for this criteria, that 60%, 30%, and 10%. So when you decide the quota for different categories, this sampling is known as quota sampling. Now, after deciding the quota, if I can go for convenience sampling or I can go for judgmental sampling. So after deciding the quota, if I go for convenience sampling, I call it quota convenience sampling. Or after deciding the quota, I go for judgmental sampling, then I will call it quota judgmental sampling. So quota sampling is not complete in it itself. You have to go for some convenience or judgmental sampling after deciding the quota, right? So there are many examples which where we use quota sampling in even in school teaching. So when you collect the data from the school teaching, you know that 90% of the teachers are female teachers, only 10% of the teachers are the male teachers. So when you are collecting the data from the school teachers, you know that you have to collect data maximum from the female teachers and very less from the male teachers, because in a school at a school level, most of the teachers are female. So when you have these kind of experiences, you go for quota sampling, and you can go for quota judgmental sampling or quota convenience sampling. So this entirely depends upon the proportion of the candidates of different categories. Then we are having snowball sampling, and this snowball sampling is quite popular nowadays because most of the cases we are not having the sampling frame. We are not having the properly defined sampling frame. So that's why this snowball sampling is going to be very, very popular nowadays. So that example which I gave you of the IT sector companies. So because at the time we are not having any sampling frame, so we say in the thesis that we applied the snowball sampling method. Now what happens in snowball sampling method, that you first find out a person and you take the reference from there. Like you can see in this example, this is the first person. You may be known to this person. You approach this person for the data collection and ask for the references. So this person give you two references, reference 1 and reference 2. Then you try for reference 1, then reference 2, and ask for further references. This person give you 3 responses. This lady is also giving you 3 references. So right, so these 3 references will give you other references. So this is called snowball sampling method. Snowball sampling method. So basically, you are collecting the data set only on the basis of the references. Now, when we should go for snowball sampling, you should go for snowball sampling when you are not having any specific sampling frame. Right. So simple, when sampling frame is not available, you have to go for snowball sampling. And sometimes, like in one of the study I'm telling you, we were doing the study on the collectors. Basically, there are many people who fond of collecting the antique pieces. This is a hobby, and the researcher want to do a study on the collectors. So in that study, because you cannot find out collectors in any social platform or in any other platforms, so first of all you try to find out one collector, then you take references of other collectors, because all the collectors know each other. So with the help of snowball sampling, we collected the data of 300 collectors. So whenever you are not having any sampling frame, in that case you can use this snowball sampling method, which is very, very helpful in some of the cases. Now after that, and we are coming to this random sampling, probability sampling. Now I'm going to tell you the probability sampling. Before moving ahead, let's see what we have discussed in non-probability sampling. We have discussed the convenience sampling, where whosoever is available, you collect the data from there. In judgmental sampling or purposive sampling, you decide the criteria and then collect the data. Quota sampling, first you decide the percentages of different categories, then go for the data collection. In snowball sampling, you take the data from the references of the references. So I called references of the references sampling. Now, after understanding the 4 non-probability sampling, now we are moving to the probability sampling. So let's discuss the probability sampling. The first method of the probability sampling is known as simple random sampling. Simple random sampling. So what is simple random sampling? Simple random sampling is simply the lottery method. So when you are adopting the lottery method, this method is known as simple random sampling. Now you know that there are 2 types of lottery. The one is called manual lottery method, and second is known as computerized lottery method. So there are 2 types of lottery method. One is called manual lottery method, but you know that manual lottery method is not possible in sampling. So we always go for simple random sampling. Simple random sampling means you apply the function, Excel function, and whosoever is coming out, and you collect the data from there. So simple random sampling is based on the computerized lottery method, and it's just a simple lottery method. So the second method after the simple random sampling is called systematic random sampling method. In systematic random sampling method, we identify the first by simple random sampling, and then we go for systematic random sampling. So I'm giving you one example. Suppose I have 100 respondents, I have 100 respondents, and out from these 100 respondents, I want to pick 10 respondents. So there are 100 respondents. From these 100 respondents, I want to pick 10 respondents. So I just divide 100 by 10. This is 10. So first, I will pick any one from the 10 respondents. For suppose these are the 10 respondents, and I apply simple random sampling, and I got the 7. So I will take the data from 7th respondent, and all other respondent will be 17th, 27, 37, 47, like this. So first person comes by the random sampling, and all other comes by the equal distance. 7 plus 10, 17, 17 plus 10, 27, like this. So this method is called simple random sampling. Like, for example, there are 1 lakh elements in the population, and a sample of 1000 is desired, right? So what we do, we divide 1 lakh by 1000. So in this case, the sampling interval is 100. So how the sampling interval will come? In sampling interval will come after dividing the 1 lakh by 1000. So this is called sampling interval. Like, for example, I divide it by 1000 and I will got 100. So sampling interval, which is noted by K most of the time, is 100. Okay, so now I divide this sample into 100. So I will pick any first from the 100, and suppose it is coming out to be 57. So the next person will be 157, 257, 357, and 457, and all. So the first person from the sampling interval is this, and after that I just add 100 to it and will get my samples. So this is called sampling, systematic sampling method. Okay. So if, for example, this number is 23, so I'm finding out any number between 1 and 100, and suppose this number is 23, so all other number will be 23, 123, 223, 323, like that. After systematic random sampling, we are having this stratified random sampling, which is quite popular. You know that stratified random sampling is a method when we divide the population into different strata. Strata means homogeneous subset, homogeneous subgroup. Like we can say that teenagers belong to one group, young people belong to one group, right? The businessman is one group. So when we divide the population into different groups, different homogeneous groups, this is called stratified random sampling. So stratified random sampling has 2 stages. In first stage, we divide the population into different subgroups, and then we apply some random sampling. Then it is a combination of 2 stages. First, dividing the population into subgroup, and then go for the random sampling, right? So normally we divide the population on the basis of demographic profile. We can divide the population into male and female, or young, middle, old people, or on the basis of designation, like junior managers, senior managers. So after dividing the population into different strata, then we are applying some random sampling. So this method is called stratified random sampling. Okay, and in most of the cases, it is proportionate. The elements within the stratum should be homogeneous as possible, but the element in different strata should be heterogeneous as possible. So one subgroup is said to be homogeneous, and other group is said to be different from the first group. So there are 2 types of stratified sampling. One is called proportionate stratified sampling, and the second is disproportionate stratified sampling. The proportionate stratified sampling is very easy. For example, you know that there are 80% junior managers in the company, and there are 20% senior managers in the company. So you divide the population into 2 groups, junior managers and senior managers, and you are collecting the 80% of the data from junior managers and 20% from the senior managers. So this is called proportionate stratified sampling, because you are keeping the same proportion in the sample. And if you are not keeping the same proportion, then this is called disproportionate stratified sampling. And then we have cluster sampling. It is very easy sampling, like, because in most of the cases we do the cluster sampling by in Delhi and NCR. Whenever somebody write in the thesis that I'm going to collect the data from the employees who are working in the Delhi NCR companies located in Delhi NCR. So whenever this Delhi NCR comes, we divide Delhi NCR into locations, like Ghaziabad is a part of Delhi NCR, then Noida is a part of Delhi NCR, Bahadurgarh is a part of Delhi NCR, Faridabad. So Gurgaon. So we divide the Delhi NCR into different areas, sub areas. Similarly, if you go to the Chandigarh, you know that Chandigarh is divided into different sectors. Mumbai is divided into different areas. right? This is South Mumbai, this is North Mumbai, this is West Mumbai. So when you divide the city, or when you divide the area or region into different sub-regions, and then you decide to collect the data from each region, this is called cluster sampling. So in cluster sampling, we divide the area, we divide the city, we divide the state into different areas, and then we decided to collect the data from each area. So it will come in the cluster sampling. Okay, again, it is proportionate or it is disproportionate. Like for example, in Delhi NCR, if you compare Delhi and Ghaziabad, it is you know that Delhi is quite big as compared to Ghaziabad. Similarly, Noida is bigger than Ghaziabad. Gurgaon is smaller than Delhi. So when we keep the size, when we keep the sample size from different areas as according to the proportion of the population, then this is called proportionate cluster sampling. Otherwise, it is disproportionate cluster sampling. So now we are having different stages of cluster sampling: one stage, two stage, multi-stage. Because within cluster, you can further go for random sampling or stratified sampling like this. So we can make different stages, and in most of the cases, we follow not a single sampling method. Rather, we go for different sampling method. Like first of all, we go for cluster sampling, and within cluster sampling, we can go for stratified sampling. So it is a kind of multi-stage sampling, right? So we are having different stages of the sampling. So these are the different strength and weakness of the sampling techniques. But if you ask me in practical, the most of the time we go for uh, judgmental sampling or snowball sampling, because they are practically they are giving you a lack of biasness and the chances of getting good data. So if I remember, in around, if I conducted suppose 100 thesis, 100 research projects, in 100 research projects, 80% times I use purposive and judgmental sampling, and in 10% the second most popular sampling is snowball sampling, and then we go for stratified random sampling. But the proportion of stratified random sampling is very low, and the cluster sampling is also very low. So most of the time we use judgmental sampling, the number one method I found in the research. And even if somebody is doing convenient sampling, I suggest them to convert into judgmental sampling. And snowball sampling nowadays are getting a lot of popularity, because most of the time you're not having the sampling frame. I mean the list of the population units. So judgmental sampling, snowball sampling are the most popular sampling methods nowadays. And random sampling we cannot apply, because in random sampling you must have the list of all population units where you can apply the lottery method. So in practical, if you think practically, we never have the data of the target population. So applying the lottery method is just impossible. So that's why when your population is infinite, and you do not have the list of 100% members of the target population, the chances of applying random sampling is very rare. But I have seen that many scholars converted the sampling method into random sampling. For example, in one of the theses, I found that the scholars write in the way that I pick the data of 300 shoppers from the different malls, and I applied the random sampling method. So then the question is that how he can apply random sampling method. Then he wrote that first of all there are 30 days in the month, so I pick any 5 days randomly. Then there are, I make a list of the malls in Delhi and NCR. I pick the any mall randomly on any day, and then I pick, there are so many visiting times, then I pick visiting times randomly, and then I go randomly. And so anybody uh, who from whom I collect the data, I pick randomly. So my all these selections are random. So that's why this is called random selection, random sampling method. So this is just a manipulation of the data collection method. But actually, even if he followed this method, can we say the chances of anybody to be the part of the population sample is equal or not? So here we cannot say the chances of everybody to be the part of the population to be the part of the sample is equal. So there is a debate on this whether we can call it random sampling or not. So I hope you understand the different sampling methods where we can apply which method. Okay, now I'm moving to the most important part of the class, that is called determination of the sample size. Because I hope you will come to know different methods of the determination of the sample size. In almost every paper and every thesis, I have seen that they will ask you one thing: justify your sample size. How you calculate the sample size? Justify that, right? And if you are not able to justify the sample size, you know that your thesis can come for the revision. So you have to revise the thesis if you want to avoid these circumstances. So you must know the methods which you can use for justify your sample size. The basic approach of calculating the sample size depends upon the three aspects: the variability of the population, the confidence attached to the estimate, and the margin of error. So these are the logic where you can decide that whether I will go for large sample or I will go for small sample. So first of all, you have to decide that what is the variation in the population. If the population is highly varied, then it means you have to collect more data set. And again, if you want to be more confidence on the output, on the results, then obviously you will go for larger sample size. Then margin of error, higher the margin of error. Basically, we keep the margin of error as 5%. And if margin of error is less, it means more sample size. If margin of error is low, less sample size. Now I'm telling you one concept from where we derive the formula for sample size. So let me go to the whiteboard and tell you the basic. So first understand this, and then we will go for the formula side. Basically, this is a population, and suppose the population mean is mu, and we take a small sample from it, and we calculate the sample mean. Right now, the question is that can we say the population mean is equal to sigma? May or may not be. I'm giving you one example. I want to know that what is the average salary of a MBA student who did MBA from let's say a category institute. So suppose the population mean is 12 lakhs, right? This is just an assumption. Suppose somebody wrote that the MBA students who pass out from a tier college, A means top 20 or top 30, you can understand like that. So the average salary is 10 lakhs, right? 12 lakhs. Now I pick a sample, a small sample of let's say 100 students. Now, can I say the average of these 100 students is also 12 lakhs? So answer is no. No, this cannot be equal to 12 lakhs because some error is there, right? Some error should come in the sampling process. So now how to address that sampling error? So I am saying that there is a sampling error. Sampling error means the mu population mean cannot be exactly equal to the sample mean. So some error is possible. Now how to define that sampling error? Now for that we are having a formula. That's suppose we are having the mean and we are adding the sampling error. This error is possible due to the chance. Now, how we calculate the sampling error? The sampling error depends upon three aspects. The sampling error depends upon the three aspects. Number one, confidence interval. Confidence interval. Number two, variation in the sample. Number three, error, right? Sample size. So these are the three inputs because of which the sampling error is possible. So we define the sampling error as Z standard deviation by root n. So this is the measure of sampling error, and this concept is called margin of error. So you have to understand this concept of margin of error. Now what happens? How to define this margin of error? Now let's say I pick a sample and find that their average salary is 9 lakhs, right? So I want to know that what should be the salary of the population. So somewhere the population of the salary lies between 9 plus minus margin of error, right? So in this way we can have a lower limit and the upper limit. So this is 9 minus margin of error is the lower limit, and 9 plus margin of error is the higher limit. And on the basis of that we derive the population distribution, and we say that we are 95% confident that population mean will lie in this range. On the basis of the lower limit and the upper limit, we derive the lower limit and upper limit and say that the 95% of the population have mean within this range. So this is the concept of margin of error. Okay, but this margin of error is very important for calculation of the sample size. Why? I say that suppose I keep my margin of error 5%. I keep my margin of error is 5%, or let's say it is E. So what is my formula for margin of error? This is N. Sorry, this is the margin of error is Z sigma is the standard deviation of the sample, and this is the sample size. So I can write here Z multiplied by sigma is equal to under root n to the multiplied by E, and I can also write that Z sigma upon E is equal to root n. So now from here I derive the formula that n is equal to Z square, sigma square, and E square. So this is the formula which we use for calculating the sample size, right? So this formula is actually coming from the margin of error. Now if I show you the PPT, so I just write this formula here, and this formula we will use for calculating the sample size. But I have discussed this formula with so many professors, and I'm also asking you the same thing. In this case, the Z value is constant. It is 1.96 for 95% confidence level. This value is constant. This error is also constant. I keep 5%. So E is constant 5%. Z is also constant 1.96%. The only variable of the sample is sigma. This is called variance. Variance of the sample. Now my question is that because in a questionnaire we have 30 variables to 100 variables. So this is the variance of which variable? So कौन सा वेरिएबल लें, कौन से वेरिएबल का वेरिएंस लें? यहाँ पे मेरा ये सवाल है, और ये सवाल मैंने कई प्रोफेसरों से पूछ लिया कि ये वेरिएंस कौन सा वेरिएंस है. Actually, I have read so many books also. Nobody, I can tell you, nobody knows that ये वेरिएंस कौन सा वेरिएंस है. So this is the biggest problem I found in this formula, right? They do not know which variance is this. And in books it is mentioned that it is a population standard deviation. But do we know the population standard deviation? The problem is that, do we know the population standard deviation? No, right? So how to find out this population variance? Right? I hope you understand my problem. So because if you do not understand this problem, you cannot understand the formula. So let me explain you once again. This is the formula which is mentioned in almost every statistics books. In all these statistics books, they mention that the sample size can be calculated by this method, and this method is nothing. It is calculated from the confidence level, that mean plus minus that Z sigma upon n, and this value is known as the error. And in most of the cases we consider 5%. So when I say error is equal to Z sigma upon root n, so we calculate this value of n is like this upon E square. So this is the formula that is mentioned in almost every book. Now in this formula, the biggest problem that I face is that what is this sigma? How we calculate this sigma? Because Z is always 1.96. The error is always 5%. Now how can I find out the value of Z? Right? How can I find out the value of sigma? So this is the problem. Okay. Now, if you have answer of it, please give me the idea. So this is the biggest problem that I found, how to find out this sigma. Okay. Now, what actually the researchers are doing, I'm telling you. Most of them, they assume the sigma is 0.5. Most of these scholars, they assume that the sigma is 0.5. Right? Now I'm telling you a game so that you can understand the concept. I'm moving to the Excel file and showing you how to use this formula. Let me show you the game of sample size. So I'm going to open Excel file and let's show you how to play this formula. This is the Excel file. Okay, now let me calculate the formula. So we are having the Z value, which is 1.96. I hope you can see the Excel file. Then I'm assuming that margin of error is 5%. Then I'm taking the assumption of sigma. This is 0.5. Or you can assume that it is also 50%. Now what is the sample size? what is the sample size if I assume all these things. So my sample size will be Z square multiplied by the sigma square and divided by the margin of error square. So you got a value, and this value is known as magic value, right? So I just write here this 384 in area of sample size determination. This is called magical value. Magical value of sample size. So I have seen that 99% of the scholars, they do this kind of manipulation and say that my sample size should be 384. And in case if you want to reduce this sample size, you just do one thing, you change this value to 0.4, and now you know that the sample size is 245. If you change this value to 0.3, the sample size is 138. If you change this value to 0.2, the 61. So in this way, you can decide your sample size by doing this manipulation. And if you want to increase the sample size, make it to 0.6. So 0.6, you will have the 553, 0.7, you will have the 752, and 0.9, you will have 1244. So because Z, you cannot change. Z is a constant value. Margin of error is 5% because confidence level is 95%. So because confidence level is 95% in almost every study in the social science, so margin of error you have to assume to be 5%. The only thing which you can manipulate is point sigma. And in most of the cases, they keep it 0.5 so that you arrive at a magical figure of 384. Right. So this is the game of the formula of sample size, and all of you should know this. Now I am moving to back to the slide. So I hope you understand what is the game behind this formula, and if you know this game, you can manipulate the sample size as per your requirement. And most of the people do not know this game, so whatever you show, you can argue on that and you can justify your sample size. Okay, now we also have this formula. In some cases, we do not know the variation. We understand the population. This P is the population proportion. So in that case, you can apply this formula also. And in this case, suppose you are saying that my population is 50%. My population is 50%. Like for example, you say that because I'm collecting the data from female, and female are the 50% from the population, so I will use this formula. And so in this case, you can apply the formula like Z square upon E square, and P is 0.5, Q is also 0.5. So apply this formula for this. Because I remember that in one of the cases, the patient, the doctor is collecting the data from the patient, and he say that the patient are 20% of the population in any country. So my P is 0.2 and my Q is 0.8. So when you know that your population is percentage of the population, then you can apply this formula. But it is also very rare. I found this formula in medical science where they quote that they claim that the patient consists of 20% of the population, like that. So there you apply this formula. And if you do not know the population proportion, you do not know the variance also, then you keep this magical figure for your sample size. And in this case, everything is constant. Z square upon 4 E square. This is everything is constant. So whatever value comes, you can decide your formula according to that. But we are having more practical methods as compared to these formulas, which I'm going to discuss now after this. So I hope you understand the game of the formula in this. And if you understand the game, you can apply this formula. But I'm telling you, we are having more much better methods, which I'm going to discuss. So one of the formula I found is Nanelli principle. So Nanelli principle is one of the most popular method quoted by the researchers. They say that first of all, you count your scale variables. How many scale variables is there in your study? So first of all, count the scale variables. And if you have 45 items in your study, it means you must have 450 sample size for the study. So there should be, so what this formula say, there should be at least 10 cases for each item in the instrument being used. Thus, if we go by this assessment, an overall sample size of around 450 would be deemed sufficient as in totality if we deal with around 20, 45 items. So if you have a questionnaire and you are having 30 items, then 300 sample sizes is required. So Nanelli principle is the most famous principle for explaining the or justifying your sample size. So you must know that if somebody asks you that why your sample size is 300 or 400, you can say that I'm measuring the 550 statement or 300 statements. So my sample size is more than 10 cases. So this is the justification of my sample size. And the second method I have seen the researchers applied, they calculate the KMO estimate. And if KMO estimate is more than 0.5, uh, more than 0.7. So if KMO estimate is more than 0.7, then you can say my sample size is adequate. Whenever you go for factor analysis, you can calculate the KMO status estimate. And if KMO estimate is more than 0.7, then we can say that the sample size is adequate. And there is a book. The name of the book is Zygmunt, Business Research by Zygmunt. So I read, when I read that book say that actually, if you feel, this is a subjective judgment of the researcher, what he feels. So you can ask any 5 experts and ask them what sample size should be there in my study, and whatever number they are suggesting you should be a representative sample, right? So it is a subjective issue. Whatever expert in your area suggests you, whatever sample size is suggested by the experts, go to that sample size. This method is called representative sample method. It is suggested by the sample size which is suggested by the experts is known as representative sample. After that, there is one more important method, and I have seen anybody who know this Bartlett sample size determination table. They more than 90% of the scholars I found, they recommended or they used this table for justifying the sample size. I'm showing you the table. This is the table of given by the Bartlett. So this table is the most popular table quoted by the researchers. And this table, first of all, let's understand this table. If your confidence level is 95%, you will use this portion. If the confidence level is 99%, you will use this portion. So in this confidence level, right, so you can decide your margin of error. Like for example, with confidence level of 95% and margin of error is 95%, 5%. If your population is 1,000, this is the population size you can see. If your population size is 1,000, the sample size of 270 is enough. Now, what is the surprising thing you can see in this picture? The maximum sample size suggested by the Bartlett table is 384. As I said that this 384 is a magical figure. So if you have sample size more than 384, you can justify your sample size. For example, according to the Bartlett table, you can see if the population up to the population of 30 crores, up to the population of 30 crores, right? Up to the population of 30 crores, 384 sample size is sufficient with confidence level of 95% and margin of error 5%. So if your sample size is more than 384, you do not have any problem, because you cross the magical figure as described by the Bartlett test of population size. So this table helps you a lot if your sample size is more than 384. And in case if your population size is 50,000, then 381 is sufficient. If your population size is 10,000, then 370 is sufficient. So in this, you can find out your sample size suitable for your study as per the Bartlett table. Now, I hope you understand the Bartlett table size determination table, which is very, very important table for many scholars. And after that, I also find out this criteria. This criteria is called Bentler and Chow criteria, because actually I have faced many studies where the sample size is 200, 150, like 150, 200. So then we think we should have some criteria where we can justify our sample size, because if you collect the data from senior management or very rare people, it is very, very difficult to collect the data from 300, 400 people. In that case, we have the sample size of 150, 90, 120. So if you have this kind of problem, then you can use this Bentler and Chow criteria. Now, what is this Bentler and Chow criteria? The Bentler and Chow criteria say that if your data is normally distributed, and you are satisfying the criteria of 5 cases for each skill variable, then your sample size is sufficient. So for example, in a research study, if 50 variables are included, then minimum sample size of 250 is needed. right? So I hope this Bentler and Chow criteria will help you a lot, and references of all the formulas are given in Google. Uh, After this lecture, I hope you have clarity about the sample size, and you can deal